Good morning, everyone. We are going to get started here in just a few minutes. We are letting people have an opportunity to join today's webinar. So if you will bear with us, we'll get started about 2 to 3 minutes after the hour. For those who just joined, you are in the right location at the right time. We are waiting just a few minutes to give other people an opportunity to join today's webinar. We will get started in just a few minutes. Okay, we're at 3 after. We're going to go ahead and get started. Hello and welcome to the Ohio Safety Processes and Funding Course Webinar Series, Part 3 of 4. My name is Paula Hyman and I'm filling in for Victoria Beal from the Ohio LTAP Center. Before we begin, a couple of housekeeping items. I see some of you have already typed into the questions box. We can tell you've been here before. But if you have questions throughout the presentation, I ask that you do type them in the box. Go ahead and put your hi, hello, good morning, whatever you like in there to make sure your questions box is functioning correctly today. Um, Lastly, today's presentation is available to download in the handout section. If for some reason you are unable to download the handouts, just put your email address in the questions box and I'll email it out to you. I want to thank you in advance for your participation. All questions will be answered by the panelists. I'll read them off, or they'll get the questions that you type in the questions box, and they'll respond to those during breaks in the presentation today. So thank you in advance for your participation, and I'm going to pass things off to Jeremy Thompson, our highway safety engineer. Jeremy?
Thank you. I'm Jeremy Thompson. I'm a highway/traffic safety engineer with the Highway Safety Program in the Office of Program Management. Joined today to present are Ray Brushhart with LTAP and Dirk Gross with the District 6 Planning Division. He's a transportation and safety engineer District 6 covers the central Ohio region. So the first two parts of this webinar that we've already covered went through a general overview of ODOT's highway safety program and the types of projects we fund and why we fund them, and how even to get funding for the lead up to a project, safety studies and stuff. And part two went through a couple project examples of a traditional spot safety project with both rural and urban context, and how they went through the whole process from the initial study and crash analysis to project funding. Today we're going to be covering some more systemic treatments and systemic safety projects that have come through our program, and how they were applied for. And tomorrow, the part 4 of 4, we're going to go through the pedestrian safety improvement program, which is also a systemic safety project, and a couple other projects that are systemic in nature, but a little more data forward and it's innovative for our program. Go to the next slide, Ray. Today's learning objectives, by the end of today, you'll hopefully be able to explain the purpose of the ODOT Highway Safety Improvement Program that we've covered the last two webinars as well. Understand the reasons why we need to install roadway safety improvements in a systemic manner. Discuss 3 objectives in our strategy to lower roadway departure crashes, and discuss at least 3 different systemic safety improvements for each of the 3 objectives. And I just want to review the Highway Safety Improvement Program requirements before we get started in these systemic projects. Once again, it's a federally required program, and the goal, we use towards 0 deaths as our catchphrase. It's to reduce all traffic deaths and serious injuries on public roads in the state of Ohio. We get $158 million annually, and typically we fund 90% of a project and ask for a 10% local match. Although this year we have been funding 100% of projects with some additional toll revenue credit that we do have. Any public road is eligible for HSIP funding. Typically the minimum threshold is 10 crashes over a 3-year period at that spot or segment. The requirement can be waived if we see a high proportion of severe crashes at that intersection or segment. Any activity consistent with our Strategic Highway Safety Plan, or the SHSP, and correct or approves the highway safety problem is eligible for funding. The SHSP activities or emphasis areas, we like to call them. It's a list of about a dozen emphasis areas like roadway departures, intersection crashes, pedestrian and bicycle crashes, work zone crashes is a new one on this year's SHSP. And ineligible activities for direct HSIP funding include education and enforcement, although those are commonly tacked on to infrastructure projects. Our traditional applications that these projects that we're presenting normally go through. We accept applications on the 30th of April and September, with the committee reviewing the projects in the following months, so May and October. Abbreviated applications are accepted at any time all year, and those are typically for smaller improvements that total $500,000 or less in construction cost. And applications are reviewed, the traditional applications are reviewed by a multidisciplinary committee made up of multiple members, both central office and various districts at ODOT. Our traditional safety project can award up to $10 million for a single project. Typically, we're in the $1 million to $5 million range for these projects, but for larger, let's say, interchange projects or just corridor projects, they can go up to that $10 million mark. And what we're going to be talking about today, systemic treatments, they're typically low-cost treatments, or at least each individual treatment is low cost, that can be bundled together to implement across tens to hundreds of miles of roadway. So we get that cheaper unit cost with systemic treatments, and some examples of these treatments, so including what we're going to go through today: upgrading signs on curves, um, installing backplates on signals, installing advanced detection on a corridor of signals, installing edgeline rumble strips, and what we're going to go through tomorrow, some low-cost pedestrian safety improvements like high visibility crosswalk markings can be done in systemic fashion. And with that, I'm going to hand it off to Ray to go through our first example.
All right, thank you, Jeremy. Appreciate that. A little bit about systemic treatments is that they're part of the Federal Highway Administration initiative called Everyday Counts, and they're up to round 5 of the Everyday Counts, and they call this their Forward initiative. And Forward stands for Focus on Reducing Rural Roadway Departures. And so that's one of the reasons that we focus on these systemic treatments, especially on our 2-lane rural roads, because those are some of the worst crashes that happen out there on our 2-lane rural roads. These roadway departure crashes. If we take a look at some national statistics, there's usually the number of traffic fatalities every year is around 35,000, and in Ohio, recently, I don't think that's the most recent number, but we had 1,083 fatalities one year. I think we're actually over 1,100 last year. And if we take a look at the rural crashes versus urban, we start to figure out why we need to focus on rural areas, because um, the number of lane miles in rural areas is actually pretty low compared to our urban roadways, but yet they're responsible for almost half of all roadway fatalities. So they're overrepresented there in the statistics. And so it means there's a problem. And so we need to see what we can do to lower these type of crashes in the rural areas. And this breaks it down a little further. And you see that's right around a third of all roadway fatalities nationally and in Ohio are rural roadway departure crashes. And so, first of all, what is a roadway departure crash? And so the Federal Highway Administration defines it as a crash in which a vehicle crosses an edge line, a center line, or otherwise leaves the traveled way. So it's a crash that happened where the car was basically not entirely in their lane of travel, or they've completely left their lane of travel. So you see a picture of a rollover crash on the left, and most likely a head-on crash on the right. And so those are both listed as roadway departure crashes. And so why do we need to focus on every state? So here's some statistics from every state listing the number of rural roadway departure crashes in each state. And some states are significantly higher than the 34% average, like Florida and California. Let's take a look at Florida and California. Um, but they're actually lower percentage, but they have large overall numbers. So the number of rural roadway departures is still high um, with their overall crashes. You can see 334 of those fatalities for rural roadway departures was in Ohio. Okay, so every state publishes a strategic highway safety plan, and so Ohio has they call it SHSP, but it stands for Strategic Highway Safety Plan. And in that, we list a bunch of goals, but some of these goals relate to lowering the number of rural roadway departure crashes and lowering fatalities and serious injury crashes. And so, this year, Jeremy's office is going to be publishing a new strategic highway safety plan. And you see some of the goals always include reducing the fatality rate by a certain percentage every year, and then reducing the number of serious injury crashes every year, things like that. And so this initiative called Forward, its mission is to reduce the potential for serious injury and fatal roadway departure crashes on all public rural roads by increasing the systemic deployment of proven countermeasures. And so we have the picture on the right showing that it has the 4 pillars of the initiative, being that we're going to use proven countermeasures, and that by that we say that they've been used, have been studied. They're all listed in the Highway Safety Manual, so we know that if we use those, we are going to reduce crashes, and we apply them in a systemic approach, and I'll get to what exactly that means in a second. And we're supporting that all local governments come up with safety action plans and include these treatments in their safety action plans, and to use these on all public roads. And so why all public roads? Well, if we didn't do all public roads, we only focused on state, then we'd be missing out on a lot of crashes to prevent, because about half of all crashes are happening on these type of crashes are happening on local roadways, both rural and even urban roadways. If we take a look at some Ohio specific statistics, we see that there's 121,000 miles of public roads in Ohio. Only 16% of those are maintained by the state. 84% are maintained by local agencies. So we really need to assist local governments in reducing their roadway crashes. And so 62% of serious injury crashes and 55% of fatalities occur on local roadways. And as far as roadway departure, serious injury and fatal crashes go, 55% of those occur on local roads. And we can break that down further and say that 24% happen on county roads, 22% on city streets, and 9% of those occur on township roadways. So how do we go about addressing all public roads? So here are some examples of how ODOT addresses all public roadways in Ohio. We have some funding opportunities for the locals. They will have access to all their crash data, which includes any compilation and summary of that data. We help them with project development and materials procurement, and also contracting assistance. The Forward program, I see somebody asked a question. That is a federal initiative, but we assist with that here in Ohio, and to assist locals with that. Part of the Everyday Counts initiative, which is FHWA. And also, how do we in Ohio address all public roads? We, as we talked about in our first part of this webinar series, we talked about the Local Safety Assistance Program, which is part of Jeremy's office in ODOT's Highway Safety Program. So as part of that, we've allocated $12 million to the CEAO, or County Engineers Association of Ohio. We provide funding for safety action plans. We have a township signing program, which I'm going to talk about in detail in a little bit. We provide the GIS crash analysis tool along with free training on how to use that, so all locals can have direct access to their crash data. And also through the Local Safety Assistance Program, we have a simplified project application form, which helps to get the ball rolling on instigating the safety improvement projects that they need in their jurisdiction. So Paula, let's roll out our first polling question today. And the question is, which of these has your agency used to reduce roadway departures?
All right, everyone, the poll question is open. If you are in full screen mode, you will need to exit full screen in order to vote on the screen here. So just a fair warning, just hit the escape button to exit full screen to be able to vote. We're at about 54% voted.
All right. See if we can get 80%. Or maybe some haven't used any. Maybe that's why. What are we up to now?
66.
All right. Well, let's see the results then.
All right, closing it now. Last chance. All right, so what we have, 32% said developed a safety action plan. 58% said installed. What is RW?
Rural roadway departure countermeasures.
Well, that's why you're the smart man. 68% used the GIS crash analysis tool. 34% use simplified project application forms, and 36% bundled projects.
All right, very good. I'm surprised that that many use the GIS crash analysis tool. Very good.
Yep, majority use that.
All right. So let's ask the question, why do drivers leave the roadway? Why can't they just stay in their lane, right? Well, let's see. It could be the fault of the roadway condition. You know, what's some examples of that? Well, let's see. It could be a really bad pothole, or maybe there was ice on the road, something like that. But, you know, as people that work for the agency that's maintaining roadways, you know, that should be one of our primary goals, is to have zero crashes happen because of the roadway condition, right? And then there's also a vehicle component failure. You know, maybe the brakes went out, or a blown tire, or something crazy with the car happened that caused the crash. Collision avoidance. So a crash happened because a deer ran out in front of somebody and they instinctively jerked the wheel, and they left the road and crashed. So, or another car was coming at them and they swerved to avoid the car or a person or something. And then there's driver error. Look at that. It's bold. It's written in bold. Why do you think we wrote driver error in bold letters? Let's see. Well, first let's ask another polling question. This is a kind of a personal question, but just remember, we're not writing this down. We're not keeping records or know exactly who answered what. So let's ask, has anybody here ever been in a roadway departure crash? And if so, why did your vehicle leave its lane of travel?
We're at about 33%.
All right, well, some people might be shy, so let's just see what, let's take a look at the results so far.
All right. Majority of the group said it was collision avoidance. Next would be driver error, then roadway condition, So 38% collision avoidance, 35% driver error, 25% roadway condition, 3% vehicle component failure.
All right. So then let's ask the next question. And what happened after you left your lane of travel? Did you recover safely, get back into your lane of travel after that? Or were you alerted by a rumble strip? Or did you have or did you end up having a crash, whether it be rollover, head on or side swipe, or you hit a fixed object like a tree or utility pole or a guardrail?
So approximately 52% recovered safely, 24% were alerted by the rumble strip, 6% for both rollover and head on or side swipe, and 23% for hit other fixed object.
All right. Well, I'm glad to know that everybody turned out okay, though. Or in some were lucky that they
Doug hit
avoided
a
the
deer.
crash. Aha. You know, if you hit the deer, you actually did it right, in my opinion. But you have to hit the deer correctly. Now, what do I mean by that? Well, it means that right before impact, well, you're going to slam on your brakes, but then right before impact, you let up on the brakes. So the front end of your car, the nose won't be down, it'll be up. That way the deer won't slide up the hood and through the windshield. I hate it when that happens. So, but the main thing is you don't swerve if you're on a 2-lane rural road, because as we're going to learn today, there's not many good things can happen to you when you leave your lane of travel on a 2-lane rural road. You know, there's too many things that you can hit. This could cause a much more serious crash than hitting the deer. So we prefer that you stay in your lane of travel. I know sometimes it's hard to do because it's you're going by reflex and no time to think about it, right? Okay, so let's move on then. So let's take a look at the contributing causes of crashes. So as we can see in this chart, that the driver is the weakest link in the system. 93% of crashes are a result of driver error. Driver error can happen anywhere. Therefore, to address these crashes, you need to implement countermeasures that can affect driver behavior and do it on as much of the system as possible. And I want to emphasize that as transportation professionals, we can design, at least substantively, not just nominally, to reduce the likelihood of user error. And so if we take a look at that chart, it says 13% of the time it's all the vehicle's fault, and the roadway is involved somehow in 34% of those crashes, and then 93% or somehow the driver error is involved in that. As you can see, these circles overlap for different statistics there, but that's from a study published in winter of 1995, from a study from Public Roads magazine. So where do rural roadway departures occur? So let's use some Ohio-specific data on these next few slides. We're going to overlap data. So here we are in eastern Ohio. There's about 4 or 5 counties here we got data on in eastern Ohio. Like, we've heard of, there's I-77 and Caldwell, Ohio. I think that's Noble County. And the counties that surround Noble County, that's very rural areas out there. So if we look at this picture, you see some green symbols like towards the middle of the screen. Maybe can you see my mouse arrow circling that one? Every one of these green dots represents a fatal crash that occurred in the year 2014. So you've got up in the top left corner, you got 2 fatal crashes, kind of happened in the same curve, looks like, but it's a curve. But then the other ones happened in curves elsewhere in the county. So then let's go on top of that, we're going to layer the 2015 fatal crash data in this area. So the blue markers symbolize fatal crashes that happened in 2015. So they all happened, some happened pretty close to where the green ones were in 2014, but others happened in totally different areas. Now let's look at 2016 on top of that. That's with the red data. So again, those are in totally new areas and curves that didn't have fatals before. And then the purple ones are from 2017. So you can see that those happened in different areas. In 2018 are the gold ones. As you can see, those are in completely different areas. So those are represent 5 years of fatal crash data in these 4 counties. So they're all rural roadway departure crashes that were fatal. So which one of these locations should we fix first, like with a spot safety improvement? And would that do us any good? Well, our line of thinking is that it really wouldn't do us much good if we only spent a lot of money on like $1 million project to straighten out a curve, because that means that we wouldn't do anything at any of the other locations, right? So what do we do here? What have we learned? One of the things we learned is that these fatal crash locations occur in random places. So the crash locations are random. But we also learned that the fatal crash types are predictable. So one of the things that those crashes have in common is that they happen on 2-lane rural roads, mostly in the curves. So a lot of fatal rural roadway departures happen in curves. In fact, most of them happen in curves. So we need to do something about curves, right? And in Ohio rural areas, we know that we can't straighten out every curve. So we need to do something else, right? And so we'll be talking about what can we do in curves in a systemic fashion. First of all, let's talk about what are systemic safety improvements. The term systemic safety improvement means an improvement that is widely implemented based on high-risk roadway features that are correlated with particular crash types rather than crash frequency. So they're based on risk. We know that curves are a risk correlated with particular severe crash types. And so if you're taking notes, well, the reason we have the handout in a PDF for you today is you can print it out, take notes, but you can also see that some of the slides we have links in there for more information. So this is a very good publication from FHWA, the Systemic Safety Project Selection Tool. So you can download that for free. So some more about systemic safety improvements. They're particularly applicable when a significant number of severe crashes happen over a wide area. So we're talking about rural roadways, local roadways, specific crash types, curves, or maybe on a highway could be across the median type crashes. You've seen treatments on I-270 and other places where we have cable barrier in the medians between the 2 directions of the highway there. That's a systemic improvement. So these improvements supplement traditional site analysis and may include treating locations that have not experienced crashes based on risk potential. In other words, we don't have to wait until a severe crash occurs to make improvements. So as we looked at our data a few slides back, that definitely applies in these areas. So let's take a look at what are high-risk roadway features for roadway departure. We break it down from roadway features to exposure and severity to roadside features. So some high-risk roadway features would be the width of the lane, and shoulder width. If we take a look at interstate roadways, we got 12-foot wide lanes and very wide shoulders, at least 12-foot shoulders or even more. So that makes those safe. That's why the interstate travel is not the most dangerous road in Ohio. The 2-lane rural road is the most dangerous as far as the data shows us. Other things like horizontal curve radius. On an interstate, a horizontal curve is going to be super elevated and be a very wide curve designed for high speed. That's not the case on 2-lane rural roads, whether it be a state route, county road, or a township road. We've got some very tight curves, hairpin curves that you got to slow down to about 10 to 15 miles an hour at the most to get through. And so it's very dangerous on 55-mile-per-hour roads. The presence of a visual trap. I've got a picture of that coming up to show you what that is. The presence of an intersection. If you're on an interstate, you don't have intersections, do you? You've got interchanges that are designed for vehicles to merge into the high-speed traffic. And there's no angle crashes at those locations like there are on 2-lane rural road intersections. Exposure severity, there's things that can, as they increase, they have more likely to have a bad crash occur there. Like maybe the average daily traffic is higher, or the operating speed is high, the posted speed limit's high. Township roads are generally, they don't have speed limit signs, but legally the speed limit is 55. But are the roadways designed for 55 miles per hour? Definitely not. Speed differential for curve advisory. If you go 55 miles per hour through a hairpin curve, you're just not going to make it, are you? So we need to warn the motorists with advanced warning and guidance through the curve about these sharp curves. We have the advisory speed plaque listed on the advanced warning sign. That's a systemic treatment. Roadside features. The edge, risk of pavement, the risk assessment, that means maybe the edge of the pavement has a drop off of more than 4 inches. That could cause a pavement edge drop off crash, which leads to a very severe crash. Roadside hazard rating could be high with steep ditches or trees, utility poles, bridge abutments, things like that. The shape of the ditch, trees, things like that can all cause bad crashes for a roadway departure crash. So these are all things that we take into account as to where we need these systemic safety improvements on our rural roads. So there's many places to get your crash data, whether it be from your local sheriff or, but you can always get it from ODOT, and especially with the GCAT tool. But we have our crashes. Anytime the OH1 form is filled out because of a crash by enforcement, it immediately goes into our data system. Maintenance logs, the people that maintain the roadways, that they can, when they're called out to fix something because of a crash, they make a note of it and let us know how many times a guardrail has been hit, or a sign at an intersection, things like that. Or roadway safety audits, they make notes of these things as well. So these are all sources of crash data. Hey, look, we have a quote from a famous person. We can't have meetings these days without a quote, right, from somebody. So Theodore Roosevelt said that do what you can with what you have where you are. And with these low-cost systemic safety treatments, then the locals can do this. So what we want to do, our strategy with these systemic improvements is we're going to do what we can by focusing on the three worst types of roadway departure crashes. And those are head-on crashes, rollover crashes, and crashes with trees. Because if we take a look at this data, we're talking about like 77% of crashes. We can, we're getting a lot of bang for our buck here with these low-cost improvements. If we can put a dent in 77% of these type of crashes, and by also focusing on rural roads where the speed limit is greater than or equal to 50 miles per hour, and also focusing on curve-related roadway departure crashes. So this is our objective with these treatments, is to focus on these types of crashes and where the roadway is greater than or equal to 50, which most state routes and county roads and township roads are 50 or greater, right? And then focus on curve crashes as well. When I said visual trap, this is what I'm talking about. If we take a look at this picture, if you're an unfamiliar driver on this roadway, you would think that the roadway would continue straight for miles. And it probably used to go that way because that's where the utility poles are located. But sometime in the recent past, the roadway was, they put a curve in the roadway. And so apparently that must have caused some crashes in the past, because we've gone out here and put up dual advanced warning signs with the advisory speed plaque on each one. Plus, we also put the post-mounted retroreflective strips on the signs too. So they really stand out there, don't they? So one of the things about curves is that, especially in these rural areas, it actually takes some amount of coordination to drive through a curve and totally stay centered in your lane of travel. And if we take a look at crash statistics in curves, we would see that most head-on collisions happen in curves because the cars just are not staying in their lane. And so this tells us that we need to make sure that we provide advance warning to the motorists for the curve by giving them the advance warning sign. It shows the shape of the curve on the sign, and also let them know if there's an intersection in that curve as well. That's all good information to know, along with the advisory speed for that curve. And also provide guidance throughout the curve from beginning to end, like with chevrons or in the large arrow in the apex of the curve. Okay, I've gone through a lot there. I don't want anybody to doze off on me. So let's have another polling question. So when it comes to rural roadway departure crashes, you guys tell me which of these crash types are included in the definition of a roadway departure crash. There's multiple answers, so you can select more than one.
We're at about 40%, Ray.
Okay.
It's clear majority though. And you can't select more than one answer, Ray, because you said
Oh,
please
okay.
select one.
All right.
Thanks, Tom. So 69% are voting Here, let me share. 69% are voting crashing into a fixed object like a tree or utility pole. 2% hitting a deer. We know who hit the deer. And then 29% rolling over on the roadside.
All right. All right, I should have gave you a heads up to make that multiple choice, but A is definitely a roadway departure crash. You have to leave your lane of travel to hit a tree, right? Hitting a deer in a traveled way, we're going to say that's not a roadway departure crash. We'll say you hit that while you're in the lane. Rolling over on the roadside is a roadway departure crash because you're off the road, right? The right angle impacts at an intersection, that is not a roadway departure crash. Hitting a pedestrian in a crosswalk is not a roadway departure crash. So A and C were both correct. All right, good job. That one said in the crosswalk is, but it's really not. Oh, that's because I deleted an answer, so don't don't pay attention to that. Okay, so again, the definition is whoops, a crash in which a vehicle crosses an edge line, a center line, or otherwise leaves the traveled way. Okay, so here's an important slide, and that it shows us our roadway departure objectives. And so our first objective is we want to try and keep the vehicles on the road at all costs. Let's keep them on the road to avoid the crash. And the second objective is to, okay, we've tried everything we could to keep them on the road, but they leave their lane of travel anyway. So if they're leaving their lane, we want to do everything we can to reduce the potential for a crash to occur. And then a third objective is to, okay, we've done everything with 1 and 2, but they're going to have a crash anyway. So our objective is to minimize the severity of that crash when it does occur. And so we have specific treatments for each one of these objectives. So for number 1, to keep vehicles on the road, our systemic treatments include curve signage, proper pavement markings on the road, high friction surface treatments, and rumble strips, either on the center line or edge line, or even transverse rumbles to alert people of an upcoming intersection or something. So those are all systemic treatments that we install to keep vehicles on the road. And then to reduce the potential of crashes, so they've left their lane. So one of the things we like to do is provide shoulders on the roadway. You know, there's a lot of county and township roads that basically have no shoulder. So providing a shoulder gives, the highway safety manual shows us that even a 1 to 2 foot wide shoulder is better than 0. And so it goes up to, you know, anything over 6 in rural areas provides substantial reduction in roadway departure crashes. The safety edge, you know, sometimes you're driving down a 2-lane rural road, your front right tire can go off the side of the edge of the pavement. And, you know, sometimes there's like a wall of pavement built up there that's, you know, more than 4 inches deep, can provide a big problem because the motorist they jerk their wheel back to get the car back on the road, but nothing happens because the tire just rubs against the edge of the pavement instead of getting back on the road. So what does that driver do? They jerk the wheel even further. And then when the tire finally does overcome that wall of pavement, then what happens is the car overcompensates and it shoots the car left of center and could cause a head-on collision or go even further and go off the left side of the roadway. So the safety edge provides a 30-degree angle along the side of the edge of pavement, and it's been studied to show that it's very easy for the car to get back up on the roadway. A centerline buffer, if you've got the pavement width to put wider pavement markings between lanes. Obviously not every county road in Ohio has that ability, but some do, just to give further spacing between opposing lanes of travel. A clear zone, if it's possible, to remove fixed objects from the first, let's say, up to 30 feet would be really good. If you got 30 feet between the edge of pavement and being able to hit anything, and not have any steep ditches, or it gives people a recovery zone is what that does. If you leave the edge of pavement, you got room to recover and get back on the pavement safely. And then traversable slopes. That means if you're going down into a ditch, maybe the ditch doesn't have to be so steep that it causes the car to crash or roll over, and you can get back on the road. And then finally, we have our third objective, where when a crash is going to happen regardless of what we did, how can we minimize the severity? And we can do that with breakaway devices on our signs or poles of whatever's out there, and in the proper barrier or guardrail, with our putting the newest design of guardrail out there that it collapses and absorbs the crash on the end treatment. So that's what that's talking about there. Or the guardrail itself is protecting the motorist from a steep ditch or something like that, or trees, and they hit that instead of the trees or in other fixed objects. So let's take a look at some of these treatments. So we have our curve signage as a part of our first objective of keeping vehicles on the road by just putting in chevrons. Very cheap, very low cost, but if you put in the latest design of chevrons like you see there, just putting them up gives us a 25% reduction in nighttime crashes and 16% reduction in non-intersection fatal and injury crashes. It's a pretty good bang for our buck in reducing these type of crashes. How about edge line and center lines? I'm sure some of us live on county roads or township roads that's never ever seen pavement markings, but that doesn't mean that they can't be put out there. Just by adding edge line or center lines, we have a 24% reduction in rural injury crashes. And by putting 6-inch wide edge lines throughout curves, we have a 13% reduction of nighttime injury crashes. Another thing we have is high friction surface treatments. Like I said, the difference between an interstate roadway curve and a rural road curve is that a lot of them have no super elevation. And without super elevation, the only thing left to hold the vehicle on the road is friction. And so if you've gone several years, 7 or 8 or more years without resurfacing, then the roadway starts to lose its friction value. And so providing a high friction surface treatment is a low cost treatment that provides a really good amount of safety, keeping cars on the road. It's been studied. So we got 52% less wet road crashes, and you also see this treatment on ramps on highways. Like when I know when I was at the city of Columbus, we had a problem with certain ramps along 270 where 18-wheelers would tip over on these curves, and so it was studied, and it was shown that before the rollover occurred for these semis, they'd actually go into a skid and then roll over. So the theory was let's reduce the skid, let's prevent the skid with high friction treatments, and it actually really worked. 86% less of that occurrence happening. Also 24% total crash reduction in curves and 35% less total crashes on ramps. So very low cost treatment. Just apply that in the curve. We also have edge line and center line rumble strips. You used to see these just on 4-lane highways, but now you see them on 2-lane rural roads. And that's because they provide a lot of crash reduction for as cheap as they are. Plus, we've recognized that rumbles are really one of our very few tools to combat distracted driving. You know, if your drivers are updating their Facebook page and texting and things like that, taking their eyes off the road to do that. If they hit the rumbles, you know, that's their last chance to focus on the road and get back in their lane. So we have a reduction in single vehicle run off the road fatal and injury crashes reduced by 13 to 51%, depending on the areas. You know, different studies are showing up to 51% reduction in that sort of crash happening. The centerline rumble strips work on head-on, opposite direction, and sideswipe fatal injury crashes reduced by 44 to 64%. So with that sort of data, you're definitely going to see, if your 2-lane rural road that you live on doesn't have these, I can probably bet that they will in the future. And then here's some data from the Highway Safety Manual, the AASHTO Highway Safety Manual, that shows just what adding shoulders to a roadway can do for us. If you go from a 0-foot shoulder to a 2-foot shoulder, that gives us a 13% crash reduction. And then, as you can see, as the shoulder gets wider, then the crash reduction gets higher as well. So turns out that shoulders along roadways are pretty important if we got the room to install them. We talked about in part 2 of this webinar series, that was adding shoulders to a rural road was one of the projects that we talked about. Then we have the safety edge treatment. It's a tool that you add to the paver, and it creates this 30% angle on the edge of the pavement, as you can see over here on the right. And so it's got more than just the benefit of reducing crashes. It also prevents the pavement from raveling, as you see in this left picture. And so it has a reduction factor of 34% for drop-off crashes, 19% less head-on crashes, 21% run-off-the-road crashes, and 11% drop in fatal and injury crashes overall. But basically, you can do this without additional cost to your resurfacing project. So why not do that? We're trying to make this a standard on all 2-lane rural roads in Ohio. So it's just something that you can talk to your contractor about. So the next is our reducing the potential for crashes. The center line, adding a centerline buffer area, if you actually have the width of pavement to do that. It shows, as you can see on the right, what we're talking about, adding like a gore area there in between the 2 lanes, and a 2-foot separation can reduce head-on collisions by 35%. And then the wider you get, the more reduction of that type of crash. Adding a clear zone, if that's possible. The clear zone, the definition of that is the unobstructed traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. And so there's a good picture of what a clear zone would look like on the right. And then you get different crash reduction value for the wider you go. So you got 3.3 feet over here. Maybe you can remove these trees here to get 16.7 feet. That gave a 22% crash reduction. And up to 30 feet was 44%. So you can evaluate this for different widths on your road for different crash reduction potential. Then we have traversable roadside slopes. And so whatever the grade is for your roadside slope, it gives you a crash reduction potential. Obviously, that top right picture looks pretty dangerous, doesn't it? That's pretty scary. It looks like something out of a horror movie. But the bottom right picture definitely shows a much safer traversable roadside slope. And then we go into part 3, our third objective, to minimize the severity of crashes. We can do this with breakaway features on our signs and luminaire supports, utility poles, and barriers to shield obstacles, including trees and shrubbery, other fixed objects, or slopes. So the top one showed no barrier, and then we have a proper barrier here on the bottom right. Okay, so that's enough about what we have as far as systemic safety improvements, some of the things that we do. So let's get to talking about a couple of our systemic projects that we have done here in Ohio. The one is from my office, but we use safety funding to make this happen, and that is our Township Safety Signage Upgrade Grant. So at the Ohio LTAP Center, we're providing funding, a grant. That means no money out of pocket for townships, so that they can all get their all 1,308 townships will have the ability to get all of the signs that they're supposed to have according to the Ohio Manual of Uniform Traffic Control Devices. And that in itself will reduce crashes on their roads. We see a picture of a very sharp S curve, back-to-back curves on a township road. And that picture basically had no signage before, and now it's got the proper signage. So we can see here it's got dual advance warning signs with the advisory speed plaque of 15 miles per hour. And then it's got guidance throughout the curve from beginning to end with the chevrons properly spaced. And it also has they upgraded from a single arrow to 2 arrows, 2 large arrows, and all of the signposts have retroreflective sheeting. So that really a dramatic decrease in crashes, and especially nighttime crashes. But with the latest sheeting, retroreflective sheeting on these signs, they really stand out even during the daytime. So very important that these townships have their curves signed properly in order for us to get the crash reduction that we're looking for. Okay, so our township sign grant, we allow up to 200 townships to apply each year based on their crash history. We rank them and invite those 200 every year. And we're on our 8th year this year, so we're getting close to the end. But we allow up to $50,000 per township to buy all of their signs. And so they receive this packet, and it tells them that they're on the invite list to apply for this grant, and that they have a crash problem, and we can help them reduce their crash problem by purchasing these roadway signs for them. The deal is we provide the signs and the post and all the hardware, but they supply the labor to install them. And so the objectives of that is with all the materials we send them is so they can learn about curve studies and sign placement around their township, and they want to find out how this program works and what their responsibilities will be, but mainly to learn about the township safety sign grant program so they can apply and help their township reduce the number of crashes on their township roads. And so what do we mean by signage upgrades? I've got some pictures here. It may be the before and after. So, if you upgrade your signage, this was the before on the left. They had small chevrons, and they upgraded to the larger chevrons, which are much brighter. So it definitely provides better guidance from beginning to end of the curve. This curve here on the left basically had no signage. And on the right, you see that they got the proper barrier marker to begin things off with, and then the proper chevrons, and the shape, let the driver know the shape of the curve, and also that there's an intersection in that curve. That's what that sign tells them. A lot of crashes were happening at that intersection because motorists just didn't know it was there. Here's a picture of a curve. You can barely see the arrow in that curve, but after they upgraded, they have the proper advance warning, advisory speed plaque, and better chevrons and a new large arrow. Those are some examples of what we do for each township in Ohio. And so a little bit more about it there, about who's eligible. And we, again, we provide all the materials, 100% covered in cost, but they commit to installing them. And so there's no money out of pocket for the townships. And the township certified. So this is all part of the training, as far as, we have to train them about what to expect and how to get through this process. So we do this every year. And we want those signs to be installed within 1 year of them receiving them. But we have been granted, we do sometimes grant extensions for that for due cause. And we also allow them to purchase signage for the villages that are located in their township. And we walk them through the process of how to determine their sign order, and we give them all their crash data as well. There's their crash map on the right for Batavia Township. It shows every crash that occurred on their township road within the last 5 years, so they can focus on the areas first that they know there's a crash problem. And again, we help them through that as well. So that's one of the systemic projects that we have, is providing the township with the proper roadway signage on all their roads. So next we have Dirk Gross, our District 6. He's a planning engineer in District 6, and he's going to talk about another systemic improvement project that happened in Franklin County on Route 62. It's actually, I think, near Gahanna. So is there a question there coming up? I see, is there a question someone had there? Do you contact the township to let them know they're eligible? Yes, we do. We send out up to 200 packets in the mail, these big packets, to let them see all the materials needed for them to apply, and they can call and talk to us. And we also have our outreach program where we contact them as well to make sure that they received it, and if they have any questions. So yes, we definitely contact the 200 every year that are invited to apply. Okay, Dirk. Dirk probably needs to be allowed to speak, Paula.
There's one more question, Ray.
Okay, let's hear it.
Is there a public list of invited townships that the MPO can see to find out if they should offer assistance to a township in their region?
That's a good question. I know that I don't think we've done that, but we've just in the recent last few months discovered that we really should do that, because got in touch with someone from the area, what is that, Buckeye Hills, that included, I think that's included in Athens County, and we have a gentleman that's recently hired there, and he volunteered to assist with all the counties, the townships that are in his region. So it would have been nice if we thought of this before. We probably would have got more participation, but we definitely are going to do that from here on out. I see we got another question maybe, or was that it? Do you contact?
One more.
Okay.
Is increasing the size of the chevron based on ADT or speed?
First of all, you don't have to do it. You can upgrade the size of your chevron. There's no police out there that say, "Oh gosh, the big problem here, someone put up a chevron too big." So, um, it should be. It could be speed. I mean, that's why we focus on helping townships, because most of the time, technically, the speed limit is 55. But yeah, there's nothing going to stop you from if you want to upgrade the size of your chevron. All right, we're going to run out of time. We don't let Dirk to begin, so let's go ahead and allow Dirk to proceed. And if we have questions after that, we'll hear them afterwards.
All right. Well, thanks, Ray. As you said, I'm Dirk Gross. I supervise the safety program in ODOT District 6 in the planning office there. And I was asked today to go over an example of a roadway departure safety project that we completed about 3 years ago. So for some background, the location is US 62 in Northeast Franklin County, between New Albany and Johnstown. A little bit further north than Gahanna that you mentioned, but it's in the northeast part of the county. So it's a 55-mile-an-hour 2-lane highway. It has about 14,000 ADT, 11-foot lanes, and about 2 to 3 foot shoulders. We had a customer complaint in November 2015 about several recent crashes at the center curve that's being shown on that image there. District 6 Safety performed a crash analysis from Walnut Street to Licking County. And Walnut Street's right at the bottom of that highlighted section there, and the county line is that dashed line to the right. So I think we skipped a slide there. You skip one? Skipped a couple. Should we go back another? Yeah.
You want to talk?
Actually skipped a bunch. Keep
Did I
going
go
back
out of
up.
order? Okay, go back up.
Wait, so background, okay, background, crash analysis. Okay, crash analysis, there we go. So on the crash analysis that we ran, we did January 2012 through November 2015. There was 25 total crashes, 15 northbound and 10 southbound. Curve 1 had 4, had 3 northbound, 1 southbound. Curve 2 had 5 crashes, all 5 of those were northbound. Curve 3 had 4 crashes, all southbound. Most of the curve crashes were wet or snow, and most of the injuries were in the curves 1 and 2. The segments outside the curves accounted for 12 of the crashes, 7 northbound and 5 southbound, consisting of passing run off the road primarily. Okay, next. So you had some fatal crashes out there. At several of these curves, so we had 4 of those, and the one in curve 3, which is towards the top, was a vehicle that lost its wheel. So not really a roadway deficiency as much as an equipment failure. And that lower left corner is what is the crash that kind of brought on the complaints in that center curve. So next. So we did a field review, and starting at curve 1, which is to the south, and then working our way up to curve 3, which is to the north. So we did a field review in December 2015, and what we saw out there, that we had curve warning signs, advisory speed 35 miles an hour, and there's chevrons. So it had plenty of signing out there. So curve 2 had curve warning. That's, again, the remnants of another crash that had happened out there just prior to the field review. So it had curve warning signs, advisory speed, and chevrons, and advisory speed 35 miles an hour. And toward the inside of the curve there, there's some utility poles, driveway. We evaluated if drainage could have been a problem. but when we observed it during rain events, we didn't find water coming onto the roadway. You can see there's really not much of a ditch there. We saw standing water in that drive, so we weren't sure if there was some kind of water encroaching onto the roadway that was contributing to any of the problems. So curve 3, and this is looking southbound towards curve 3. It had a advisory speed, it had curve warning sign, advisory speed 45 miles an hour. There were no chevrons on that particular curve. So Franklin County Sheriff was also concerned about the problems that were out there. They had complaints too. So they set up a speed trailer southbound between curves 2 and 3 for a week in mid-September in 2015. There's some battery problems that caused some night detection to fail, but for the most part, it did a pretty good job of picking up the data. So the readings showed about 7% speeding, 54 mile an hour was the 85th percentile, 50 mile an hour is the median speed, and maximum was 72 miles an hour. And again, this is 55 mile an hour speed limit out here. So because we had a lot of the run off the road on the curve, we went and requested some skid testing, some pavement testing from MoDOT Tech Services. And so in December 2015, they completed their test in by the 9th of December. So we asked for the test, and like a week later, we got the results. And you can see some of the results on there that there was some polishing that they detected in the pavement. So, and we had a resurfacing coming up in 2017. So that we did some ball bank tests on the curves, and for curve 1, it came out to a 45 mile an hour advisory speed. Curve 2 was correct, and curve 1 was originally, I think it was a 35 is what it said. So curve 2 was correctly signed at 35 miles an hour, and curve 3 was 50 miles an hour. So curve 3 was actually slightly higher than what the advisory speed showed. There's no chevrons for curve 3, but the current advisory of 10 miles an hour less than posted speed, the chevrons are an optional sign. So most of the curve crashes had possible contributing factors of insufficient friction that we saw from the pavement tests. The speeds were somewhat high based on what the sheriff had found. And we had also, there was illegal and unsafe passing that was contributing to some of the sections between the curves. So we came up with some recommended countermeasures for short term. Something getting out there as fast as we could to try and address some of the problems. We looked at the signing, and we looked at putting in oversized curve warning, advisory speed, and chevrons. That was like one of the questions we heard earlier about oversized signs. If you have the signs out there and you still have issues, you can go to an oversized sign. Also, freeway, interstate signs, ones on freeways tend to be larger also. But that's an option that you always have, is to go up to larger size sign, and that's what we decided to do here. Since we already had the signs and we were still having some of the crashes, so we went to oversized. We also had fine milling, requested fine milling to be done on all 3 of the curves, which is just a grinding operation of the pavement to try and improve the friction. Some downsides to that are that with fine milling, it can polish over time, so it's often considered sort of a shorter term fix, but that's what we were looking for here anyway. And then there's also enforcement with message boards that we had set up, warning, giving people advisory, some warning. And also there was Franklin County did an enforcement blitz on that, on this section of Roadway. For medium term, we looked at improving the friction, particularly on curve 2 with microsurfacing. We had a resurfacing project that was scheduled in 2017, and so we modified the plans for that to provide for some special paving to be done there in the microsurfacing. I'll show a little bit more of that later. And then we are also doing centerline rumble stripes to help with the illegal passing and the crashes between the curves. And we are also also put in for 6-inch edge lines, which are now the standard. At that time, that was just an optional treatment, but so we put in for the 6-inch. And then for long term, we're just going to monitor the crashes to see if what we were doing out there was being effective. So again, for the short term, we went with the oversized signs, and you can see the signs there. So those are the oversized dimensions that we had. So we went a 45 miles an hour with the advisory speed plaque, 125 feet of it in advance of curve 1, the oversized curve warning sign with 35 miles an hour in curve 2, and the oversized curve warning sign with 50 miles an hour in curve 3. We installed 2 oversized chevrons through curve 3 at 160-foot spacing, and that work was completed by the end of January in 2016. So we had done some of the testing and all that in December, and then we had the signs up by the next month. So the fine milling operation was sort of a collaborative effort between BOCA, the contractor, and ODOT. So ODOT did the maintenance of traffic control, dump trucks, and that sort of thing. BOCA had the equipment to actually do the grinding. And so they went out and they completed that work by January 2016. The enforcement blitz, results of that, they ended up with 165 stops, 18 speed citations, 133 warnings. And we had the message board placed out there from mid-December 2015 through the early part of January in 2016.
What did the message board say?
The message board was saying it was we call it enforcement zone.
Okay.
Kind of like the you see the permanent signs are out there saying this is a target enforcement area. It was that same type of message, but just on a portable message board. So
Okay.
it was just warning people that was, you know, targeted enforcement area and drive safely, that type of thing. So for the medium term countermeasures, we added some things to the resurfacing project in 2017. So you can kind of see there, we got the item 618, the centerline rumble stripe. We had special microsurfacing done through curve 2. So there's the conventional material, but here there's a little back and forth between tech services and construction and our pavement people. And normally you'd think of going out there and putting down that there's a bauxite material that they apply with epoxy on, sort of kind of gives you a sort of a sandpaper surface. But it's an expensive application, and there's kind of some pushback to going to that all the time. And it was kind of determined through our construction folks and down in central office pavement that maybe just using a better material in the paving would be adequate. And so what we have here is we specified certain aggregates in the microsurfacing to be used. In this case, they're looking for trap rock and basically non-polishing type aggregate. If you have bad aggregates, they polish and then they start to get slick, and you can then you have the run off the road problem, the friction issue. So they try to get some of this special limestone and trap rock as a part of the material just through that particular curve. So this is the chart of some of the results of the crashes that we had. So on the top, that's the total number of crashes. This is all 2013 through 2019. The more interesting parts of the crash summary sheet in the lower left corner, and then the graphs that are associated with that on the right. So what we found is, the initial treatments were done in the beginning of 2016, and you can see that particularly the fatal and serious crashes, injuries, just plummeted, went down to virtually nothing. There are total crashes. They're not gone. 2017, there was a little bit of a spike, but they all were really just property damage type crashes. But you can see the overall trend is going down. So in some of the summary here, there's a lot of partnering and coordination between agencies. It was between ODOT and the sheriff's office and even some of the local groups. We had to set up or sign on private property, and so that was, and there's a lot of assistance on that sort of thing. We had viable short-term strategies that really worked until we could get the medium term put into effect. And you can see then the results of the medium term strategies have been effective. So we took the overall crashes and cut them to less than half. And of the 8 serious injuries and fatalities prior to the improvements, we've had none after that. And I've gone back and checked even up to current, and we still have had no injuries or fatal crashes out there after the effect. And you can see in the picture there, right, that's the center line. You can see the center line rumble stripe cut into it. And that's also the curve where that special paving, the microsurfacing, has been done. And you can't really visually detect it from the rest of the pavement. We were kind of concerned that people would think that, you know, when you do the grinding, they can see the grinding marks and they can see there's something out there. And you can see when you do the conventional high friction treatment, you can usually see that application. This, you can't really see it. And so we were concerned we get some complaints about it, but we really haven't had anybody call in or anything like that. Basically, the crashes have pretty much disappeared, and so people just haven't really called and complained about anything. So it's been pretty effective, and we're pretty happy with the results. And these are some of the, again, all the different offices and people that really contributed to getting this whole plan together. And that's it.
Well, thanks, Dirk. That was a really good project. It was such dramatic results for the decrease of injury and fatal crashes through there. I mean, even the people from FHWA, like Dick Albin, they really praise the high friction surface treatment, and it's good to know that it's reflected in your project as well.
Mm-hmm.
So those are our 2 systemic examples of projects that ODOT has backed with money from the Highway Safety Program. Is there any more questions out there today?
Nope, nothing's in the box.
Well, I hope everybody enjoyed today's session, and we're going to wrap it up tomorrow with part 4 tomorrow afternoon. I think it starts at 1 o'clock, and we'll go over some pedestrian systemic treatments or other pedestrian improvements, and some examples here in Ohio. And so look forward to that tomorrow. And thanks for participating today. And thank you, Paula and Dirk. And we'll see everybody tomorrow.
Thanks, Ray.
Okay.
Thank you.
Thank you, Dirk.